Assalamualaikum, my name is Ahmad Raziq and I will explain for the two sample hypothesis test. In this analysis, we will use variables gender and monthly income. So first, we will do the hypothesis statement where if the mean of monthly income of male is equals to the mean of monthly income of female. Next, we will do the test statistic based on the 95% confidence level. As you can see, we will get the test statistic for this sample is negative 1.2223. Next, we will calculate the degree of freedom using the formula, and by using the RStudio, we will get the degree of freedom is 1261.5467. Hence, using the alpha 0.05, we reject the null hypothesis if p value is less than a. Okay, now since the test statistic p value is 0.2218, which is higher than 0.05, we fail to reject the null hypothesis. Since the null hypothesis is accepted, there is sufficient evidence to support the claim that the mean of monthly income of male is equals to mean of monthly income of female. Now this is the data visualized for box plot of gender versus monthly income using RStudio. Next, I will be explaining on the correlation test. In this analysis, we will use the variables job level and monthly income to determine whether there is a linear relationship between job level and monthly income. Okay, first, we'll calculate the sample correlation coefficient using Pearson's method. As you can see, by using RStudio, we can see that the sample correlation coefficient R is 0.9503. Next, we'll do the hypothesis statement. For the null hypothesis, there is no linear correlation between job levels and monthly income. And for the alternative hypothesis, there is a linear correlation. Okay, now for the test statistic, as you can see by using RStudio, we get the test statistic is 116.9484. Next, we'll calculate the critical value. From RStudio, we can get the critical value, which is negative t is equals to negative 2.2437, and for the positive t is 2.2437. Now for the p value is 0. Since the test statistic is higher than the critical value, null hypothesis is rejected. So there is sufficient evidence of a linear relationship between job levels and monthly income at a 95% confidence level. Now this is the significant test for correlation using RStudio, and this is the scatter plot for the correlation. Thank you.
So first, the regression equation is given by y equals to beta 0 plus beta 1 x. By using RStudio, we get beta 0 equals to 3501.33 and beta 1 equals to 20.34. And then the regression model equation becomes y hat equals to 3501.33 plus 20.34x. One income increase. And then the next one, the third one, is by using RStudio, we get the total sum of squares. This value, sum of squares error, this value, sum of squares regression, this value. And then we need to find the coefficient of determination. So this is the formula, and then we get this value. And then after that, we find the standard deviation of regression slope. So this will be the value. And then the next one, hypothesis statement, H0 is beta 1 equals 0, and then H1 beta 1 not equal to 0. And then the sixth step is test statistic. So after test statistic, we find that t is 0.24. Then the critical value, next one, for a two-tailed test, blah blah blah, the critical value is this. So this is the approximate critical value. So in conclusion, since the absolute value of the test statistic is less than critical value, the p-value is greater than 0.05. We fail to reject the null hypothesis. There is insufficient evidence to conclude that there is statistically significant relationship between age and monthly income.
So we will move on to the chi-square test of independence. In this analysis, we will use the variable gender and department to assess the independence of gender and department of employees using a two-way contingency table at a 95% confidence level. As a result, we employ this chi-square test of independence in conjunction with a two-way contingency table. To perform the chi-square test of independence in RStudio, we use chi-square.test function. So first for the hypothesis statement, uh, the null hypothesis is both of the variable are independent, and the alternative hypothesis is both of the variable are dependent. And then we calculate we get the critical value here for the chi square, which is the degree of freedom is 2, and then the significant level is 0.05. The value is 5.991. And then in the conclusion, we get the value of chi square is 2.9645. So since the test statistic value x square 2.9645 is smaller than and then the critical value 5.991, we fail to reject the null hypothesis. Since the null hypothesis accepted, there is no sufficient evidence to support the claim that variable gender and department are dependent at significant level 0.05. This implies that gender is not determining factor for the department of employees. So for the ANOVA test, we want to analysis whether if a job role has a significant effect on total working years. So we do a one-way ANOVA test at 95% confidence level. And then we perform the ANOVA test in R Studio using R programming. So for that is our hypothesis statement. The hypothesis equal to there is five different job role, and then the null hypothesis and the alternative hypothesis is at least one mean is different. So for the critical value, we get the critical value f equal to 5.19, where we get it from the degree of freedom numerator is 4, and then the degree of freedom denominator is 5, and then the statistical level is 0.05. And then we check it into the F table, and then the value is 5.19. So for the conclusion here, we get the F value equal to 1.723. Since the test statistic value, F value 1.723 is smaller than the F critical value, which is 5.19. We fail to reject the null hypothesis because it's in the acceptance region. Since the null hypothesis is accepted, there is no sufficient evidence to conclude that there are no significant difference in total working years across different job role groups. This means that the job role doesn't influence the total working years of employee.